This example and the ones that follow it are quite difficult and possibly even beyond what you might be expected to do at this stage. However, if you can follow them, you will have no problem with the questions you get asked on exams. We want to differentiate y equals sine squared 2x times cos squared 2x. We could do this just as a product, but we could also use our knowledge of trigonometric identities to make it simpler to differentiate. We know that the sine of 2a is equal to 2 sine a times cos a. It follows that the sine of 4x is identical to 2 times the sine of 2x times the cosine of 2x. All we've done is say that a is equal to 2x. Dividing both sides by 2 gives a half of sine 4x is identical to the sine of 2x times the cosine of 2x. What we're going to do now is square both sides. This side will become sine 2x times cos 2x, all squared. This side will become a quarter sine squared 4x. Note the right-hand side is the same as the expression we're trying to differentiate, so we can just differentiate the quarter sine squared 4x instead. So let's differentiate the quarter sine squared 4x, which we know is equivalent to the expression above. We could rewrite this as a quarter times sine 4x, all squared. We need to use the chain rule, so dy dx is going to be, the quarter is just a constant, the outside function is the squared, so it's 2 times the contents of the bracket to the power 1. The inside function is the sine 4x, so we'll get cos 4x, since sine differentiates to give cos, but note that sine 4x is a function of a function, so we need to multiply by the differential of the inside function again, the 4. The quarter and the 4 cancel, leaving us with 2 times the sine of 4x times the cosine of 4x. Had we approached this problem differently, we may have got a different expression. But since we were differentiating the same thing, any expression we got by doing this differently should be able to be manipulated to give this same answer.